Hello everybody, this is the first video of our deep learning playlist, and this playlist will be very different. I know there are thousands of videos around deep learning, but I haven't found a single source where everything has been explained so deeply that it can be followed by a beginner as well as by someone who is at advanced level. So in this playlist, everything will be covered from beginner to advanced level, and I will make sure that it's not just a theoretical playlist, but practical aspects are also covered. How deep learning is implemented in real world projects and how the real world projects are driven by deep learning. So everything will be covered. Stick with me. Subscribe to my channel. Bookmark this playlist, and let's start. So let's first understand that what was the inspiration behind deep learning. So scientists had a very basic question that can we mimic human brain in any way? Is there any way through which we can make our machines intelligent like human brains so that they can take decisions on their own? Can we provide the decision making capability to a machine just like humans have? They wanted a way through which they can mimic how a human brain works. So at its core, human brain is a very dense network of biological neurons. These biological neurons are nothing but a single cell, and they are interconnected, and it's a very dense network. Okay, and if I just look at a single neuron, a single biological neuron, then this is how it looks. It takes in the information through dendrite. It collects all the information that it has got from other neurons, and then there is processing that happens here, and then that information is transmitted to another neurons from here. Now the information may be transmitted or it may not be transmitted, depends on the information that you are getting. Let's say you accidentally touched a very hot mug, then the processing will happen that do I need to pull my hand away? Is it that hot? If it's not very hot, then I might not pull my hand away, right? So this neuron may not fire up. It may not transmit the information if that mug is not very hot, but it may fire up information to other neurons if that mug is very hot. So this is how the biological neuron works. Very simple, though it's very complex in reality, but we don't need to have a biological background. So that is why I simplified it for you. It collects the information, processes it, and then decides that whether you need to fire that information to other neurons or it just need to not fire. So based on this simple idea, two scientists, McCulloch and Pitts, they come up with something called MP neuron or McCulloch-Pitts neuron. So what happens here that let's say this is your neuron and you take certain inputs. Let's say you take x1, x2, x3, and there can be other inputs as well. The condition here is that these inputs will be binary. There they will take the value 0 or 1, and the output that is coming out from this neuron is also binary. Either it will be 0 or 1, and within this neuron there is certain processing happening. We will see that what kind of processing is happening inside it, but for simplicity, let's just consider the example where I am deciding whether I should go for a movie or not. If the value is 1, I will go for a movie. If the value is 0, I will not go for the movie. And what are the inputs that I am considering? That let's say my x1 is it raining outside? Let my x2 be is my mood off? X3 be are my friends coming? And just like these three inputs, there can be other inputs as well. Now, once this input, once these inputs go inside the neuron, then this G function is simply aggregating these inputs. And why are we aggregating these inputs? Because it's like collection of all the information that you are getting. Okay, so your G is nothing but simply aggregation of your inputs. It can be I from 1 to n depending on here it's 3 depending on what the value is, how many inputs you have. Okay, so it is just summing all the inputs that you are getting. It's a simple aggregator. There are complex aggregators as well. As we will move forward, you will see that there are different forms of aggregation that can happen. Now, we are by aggregation, we simply mean that we are collecting all the information we have got, or we are just aggregating all the information that we have. Now, once we have aggregated, then there is a gate. This gate is nothing but called the activation function. And what this gate does, that it decides whether it needs to transmit that information, or whether this neuron will fire, or whether this neuron will not fire, or whether it will not transmit any information further. So when I say the neuron will fire or not, that simply means that whether information will be transmitted or not transmitted. So once that information has been aggregated, this function decides whether the gate will open or the gate will not open. So what this function is, this is a function that takes the information that has been aggregated, and this function's value is 1 if the value, or the gx, this is nothing but gx, if the value of this function is greater than equal to a certain threshold, and its value is 0 if the value of aggregated information is less than that threshold. So what I am doing here, that what I'm saying is that the gate will open, the information will be transmitted, or the neuron will fire if the information aggregated has a value greater than a particular threshold, greater than or equal to a particular threshold. And if the value is less than that threshold, then I will not let this gate to open. This is what this F is saying. I will not let information transmit to other neurons. Okay, I will not let this neuron to fire. Now, what this threshold is? Let's say for this problem, I say that my threshold is 2. So, what does this mean? That if my two inputs are on, then I don't care whether my third input is on or not. I will go for a movie. Let's say if my mood is okay and it's not raining outside, then I will go for a movie irrespective of my whether my friends are coming or not. If my threshold is 1, then if my friends are coming, then I will go for a movie. I don't care whether it's raining outside or how my mood is. Or if x2 is 1, let's say I say that if it's not raining outside, then I will go for a movie irrespective of how my mood is or whether my friends are coming or not. So depending on what the threshold is, this F decides whether the neuron will fire or not. If the information has if the aggregated information has a value greater than a particular threshold, greater than or equal to a particular threshold, then the gate will open and the neuron will fire. If it's less than that threshold, then the neuron will not fire. As simple as that. So I hope this example that I gave, and what is the what is the working behind MP neuron, that is clear to you. In the next video, we will cover what perceptron is, and there are certain flows in this MP neuron. You see here, it's very simple. What if we have real inputs? What if we have real outputs? For example, instead of getting 0 and 1, I want to get value like this, probability kind of thing. And let's say instead of inputs 0 and 1, let's say I say that how many friends of mine are coming. Okay, so at that time my xt can be 4, 3, 5. It can be anything. It's not just, our inputs are not always binary, right? Those can be real valued. So this is one of the limitation. Another limitation is that this neuron, let's say I don't want to give equal importance to every input that I'm getting. Let's say for me, if it's raining outside, then that has a higher weightage, and I will give a higher weightage to that input as compared to whether my friends are coming or how my mood is. So if it's raining outside, then there is a high probability that I might not go for a movie. right? So let's say I don't want to give equal importance to every input that is coming in. I want to give higher importance to certain inputs, right? So in that scenario, our aggregator function will change a bit. We will associate weights with each input that signifies how much important my input is in firing up that neuron. So these are the two things. That first is we can't have real values associated for input and output. And another thing is, what if we don't want to give equal importance to every input and we want to have various importance associated or various weights associated with each input. So these are the two drawbacks that I can currently think of about MP neuron. And so to overcome these short limitations, we will see how perceptron works and how it covers these shortfalls of MP neuron. Everything will be covered in the next video. Everything will be covered in detail. I promise to you, subscribe to my channel. Please like this video. I really need your support. Thank you so much.